Now in the previous lecture we have implemented isFull method, isEmpty method and enqueue method using array for this linear queue over here. Now in this lecture we are going to implement Dequeue method, pick method and delete queue method. Now let's get started with Dequeue method. So here after enqueue method I'm going to declare our Dequeue method like this. So it's going to be Dequeue. So as we said before, Dequeue method returns the first element from the queue and it's going to remove that element from the queue over here. So that's why I'm going to declare our method with the return type of integer, because in this case it's going to return integer because our queue is integer queue. Then I'm going to name our method Dequeue, and inside Dequeue method the first thing that we are going to do, we are going to check that if this queue is empty or not. So if it is empty, we cannot dequeue any element from here because we don't have any element in this queue over here. So I'm going to check if it is empty. Then in this case we are going to print out to the console saying that the queue is empty. Otherwise we are going to return the element from the queue over here. Now to return the first element from this queue over here, and then we are going to use the beginning of queue index to return the value. Then we are going to change the beginning of queue and increase it by 1, because in this case that element will be removed from the queue over here. That's why I'm going to first create an integer variable over here which will be result, and set the cell value that comes from the beginning of queue to this result variable over here. So it's going to be like this, ARR beginning of queue. Then I'm going to increase the beginning of queue by 1, because in this case when we are removing an element from the beginning of queue, the next element will be the beginning of queue. So that's why we have to increase this one. Then after doing so, we are going to check that if the beginning of queue is greater than the top of queue, in this case this is the last elements in the queue that we are dequeuing. So that's why we are going to set beginning of queue and top of the queue to -1, because in this case our queue will become empty. So that's why I'll write if condition like this: if beginning of queue is greater than top of queue after we are increasing it, then in this case we are going to set both of them to -1, because as we said before, if both of them is -1, it means that our queue is empty. So here I'm going to set both of them to -1. Then at the end, I'm going to return this result variable over here. So it's going to be like this, return result. And here inside is empty part. After printing out message to the console, we are going to return -1, because in this case, if we are returning -1, it means that our queue is empty. But these values depends on your choice, so you can put whatever value you want over here. For my case, I'm putting -1 over here to return -1 if our queue is empty. Now with this, we have completed our method. Now let's see how this is working in practice. So here inside main class, we have created a queue like this, and we have enqueued 3 elements to it. I'm going to delete the 4th one because 4th one is not inserted, because our queue consists of only 3 elements. Then I'm going to create a new variable over here, which will be the type of the integer. I'm putting it to result, and I'm going to call the Dequeue method to see which element will come out from this Dequeue method over here. So as we said before, in queue when we are dequeuing element, it's going to return the first element. Now in our case, first element is 1, so when we are printing out this result variable to the console, it should print out 1. So I'm going to print out this one to the console, system out print result. Now if we run our code, you'll see that after inserting 3 elements over here, when we call the Dequeue method, it returns 1. This means that first element is removed from there and it's returned from this Dequeue method. Now if I run this one more time after this one over here, you'll see that in the second run it's going to return 2, because in this case 2 becomes the first element in our queue, so that's why it's going to return 2. So if I run our code one more time, you'll see that in the first run it returns 1 and in the second run it returns 2. So this means that every time when we are running the Dequeue method, it's returning the first element, and the first element gets removed from the queue over here. So with this, we have successfully implemented the Dequeue method over here. Now let's see what's the time and space complexity for this Dequeue method over here. Now as always, we are going to start from the first line of code. So in the first line, we are checking that if this queue is empty or not. So we know that empty method takes a one-time complexity, so that's why this if will take a one-time complexity. Then we are returning message to the console saying that the queue is empty, so this one also will take a one-time complexity. Then returning -1 also takes a one-time complexity. Now inside else condition, we are creating a variable over here and setting the beginning of queue to this variable over here. So this operation will take a one-time complexity because this is just simple assignment. Then we are increasing beginning of queue by 1. So this one also will take O1 time complexity. Then in the next if condition, we are checking beginning of queue with the top of queue. If beginning of queue is greater than top of queue, we are just assigning -1 both of them. So this if condition over here will take O1 time complexity. Then at the end we are returning results, so this one also will take O1 time complexity. Now if we combine all these complexities over here, we get O1 time complexity. And when it comes to space complexity, it's also O1 because here we are just dequeuing an element from the queue and we have not performed any space consuming operation over here. So that's why space complexity is O1. Now with this we have completed the queue method. Now let's continue to the next method, which is pick method. So here I'm going to comment out pick. Now we know that the queue method and pick method are similar, but in this case, when we are calling pick method, we are not removing element from the queue. We are just returning the beginning of queue, but we are not removing the element from the queue over here. So that's why the pick method will be like this. Public int is going to return the type of int. Then I'm going to call it pick. So it's not going to take any parameter because whenever we are calling pick method, it will return just the first element in the queue. So the first thing that I'm going to do over here, if the queue is not empty, so I'm going to put it like this. If it is not empty, in this case, we are going to return ARR beginning of queue. We are just returning it without increasing the beginning of queue. So here you see that when we are returning it, we were increasing the beginning of queue in case of the queue method, but in case of pick method, we are not doing anything. We are just returning the beginning of queue. Otherwise, I'm going to just print out to the console saying that the queue is empty and we are going to return -1. So this part is same as with the queue method. So I'm just going to copy it from here and paste it over here. Now with this, we have successfully implemented pick method. Now let's run this for the queue that we created over here. Now instead of the queue method, I'm going to call pick method twice to see the result in the console, to see the difference between pick and the queue methods over here. Now let's run our code. Now in this case, you see that whenever we are calling pick method, it's just returning the first of queue. So in the first run, it returns the first element in the queue, which is 1. And in the second run, it's also returning the first element in the queue, which is 1. So it's not changing the beginning of queue in this case. So there might be some situations that in our application, we want to check what is the first element in our queue. So in this case, we are going to run pick method. Now let's see what's the time and space complexity for this pick method over here. Now here again, we are going to start from the first line of this method. So in the first line, we are checking that if it is not empty, then we are returning the value of cell that is located at the beginning of queue. So is empty method is taking O1 time complexity. So this if condition will take O1 time complexity. And we know that accessing an element of array using their index also takes O1 time complexity. So this one also will take O1 time complexity. Then at the end, we are returning message to the console saying that the queue is empty and returning -1 over here. So these two lines of code also will take O1 time complexity. Now if we combine all these complexities together, we get O1 time complexity. Now the space complexity is O1 because here an extra space is not required to return the beginning of queue over here. So that's why space complexity is O1. Now let's continue to the next method. So the next method, the last method which we are going to implement is delete queue method. So this method is responsible for deleting queue from the memory. Now how can we delete a queue in this case from the memory? So in this case, all we are going to do, we are going to set this array that we have created over here to null. So if we are setting it to null, the cells are deleting from the memory. So our queue is successfully deleted from the memory. So inside our method, public void delete queue. So inside our method, we are going to just set ARR to null. And we are going to print out saying that queue is successfully deleted. So I'm going to put it like this. System out print then the queue is successfully deleted. Now let's see how this is working in practice. So here we have created a queue and we have enqueued elements to it. So without just calling this pick method over here, I'm going to call straight away delete queue method. So here I'm going to call delete queue. So if I run our code, you'll see that after inserting elements to the queue, it says that the queue successfully deleted. So with this, we have successfully deleted queue over here. Now let's see what's the time and space complexity for this delete queue method over here. So it's obvious that it's O1 because here we're just setting ARR to null and we are printing out to the console this message over here. So these two lines of code will take O1 time complexity. So the time complexity for deleting queue is O1. Now the space complexity is also O1 because here we are just deleting the array from the memory and we are printing out message to the console. So this means that it will take O1 space complexity. Now with this we have come to the end of this lecture. So in this lecture we have implemented 3 methods for queue using array. So in this case our queue is a linear queue. So here we have implemented Dequeue method, and we have learned that the time and space complexity for Dequeue method in this case is O1. And then we have implemented pick method, and here also pick method takes O1 space and time complexity. And then at the end we have implemented delete method. And after implementation we have checked them in practice, so everything works successfully. Now with this we have come to the end of this lecture, so hopefully everything is clear about these 3 methods that we have discussed over here. Now see you in the next lecture.